Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem. There is a number with same consecutive differences. This is a medium level problem and we'll understand what this question is asking us to say and how we can find a solution to this kind of questions. Okay, so before moving on, if you haven't subscribed to this channel yet, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. First of all, let's understand the question says return all non-negative integer of length n. So non-negative integer of length n. So this should be the length of each of our numbers. Okay, such that the absolute difference between two consecutive digits is k. Like in that number, the absolute difference between them should be k. How's it? Say if our first digit is 1, okay, and our k is something like say 2, okay, then what should be the next number after 1? It can be 3. Fine. Say our n is 2, so if our n is 2, that means it can be only two digit numbers, so that's what it says, the length of n. So that's a two-digit number. Now absolute difference between two consecutive digits, there's the two consecutive digits is 1 and 3 itself. So the consecutive digits is like difference is 2, right? So that's possible. And then if the next number is 2, then it can be 4. That's our second number that we can create. So it can return all of those. Okay, so once we return all of those, so what we need a array or a list. Let's see what the question asks us to return. Question asks us to return an array. Okay, so make sure you just convert it to an array at the end, like, because we don't know how many numbers will be created at any position. So we will take a list to create the numbers and then we'll go ahead with that. Okay, so this is a simple idea. Now after like 2, for 2 it can be only 4, but for 3, okay, when it's 3 we are looking forward, we find that 5 is the number that's possible. Also for 3, 1 is also possible. That's a different number. Why is it so? Because in number line, 1 is there, 3 is there, and 5 is there, right? Like there are number 2 and 4 are there. So for 3, for consecutive difference of 2, we can go forward and we can go backward. Okay, so that's the purpose you can do, and that's true for all other numbers, because the first two numbers 1 and 3, to like 13 and 24, we couldn't go backward. Like for 2 backwards, can we go? Yes, actually for 2 backwards we can go. That is the 20 is also a possibility, but for 1 2 backward is not possible, because that will be 1 minus 1. That doesn't make sense, or that is a not an like the non-negative integer, or okay, because that's the number we're creating. So for 13 it's not possible. For 24 we can make sure that the 20 is also a possibility. Okay, so we'll keep on adding those number if there is 2 and 2, and then ultimately what we'll do, we will return the whole list. Okay, now, as a small example, if you look at n equal to 3 and k equal to 7, so you see that the first digit is 1 is taken and the next digit is 8 is taken. Okay, and we know after 1 8, with if we are supposed to fill it 3 digits, so it's like 1 will again come in. Okay, now further, what we can see, 181, then for 2 it's 292, and then we go ahead to 707, and then we go find 818 and 929. So other than this, no other numbers are possible for n equal to 3 and k equal to 7. Right, now the question is how we should think on finding this solution. Okay, now look at the constraint one. The constraint is n, this length of the numbers. This ranges from minimum 2 till 9. Fine, if it's a 9 is the input, then how it can actually work. Okay, then our, can we go ahead with the 1? Because if our first digit is 1, okay, okay, the next thing we need to know, like that will be more or less like when n is 9, that means it is like 9-digit numbers are need to be created. Fine. Let's not explore that because there's no complexity. Let's think on this like zero, like for the k, like the consecutive digit difference. If the consecutive digit difference is 9 itself, fine. Then what we can go ahead with? We can go ahead with something like uh, simply we can go ahead like if a first digit is 1, can we put any other digit that has a difference of 9? Because if we put anything that will become 10, right? So is 10 possible as a single digit? No, that's not possible. So we cannot start with 1, we cannot start with 2, we cannot start with 3. Also, can we start with 0? No, we cannot start with 0 because the further question says the answer must not have a leading 0. Okay, so we cannot start with a 0 also. So that's not a possibility. So what we can start with? We can start with 9 in that case. Okay, we can start with 9 and we can go to 0. Fine, that's a possibility if k is 9 only there. I'm just discussing the cases, right? Now let's understand how we can think on like finding a solution to this. Once we understood what we are supposed to do, we need to understand what we need to do. Now there can be two ways to like it's kind of a two ways to find a solution, but like two ways in the sense, I mean, you can do go ahead with a BFS approach or with a DFS approach. Okay, but let's, before complex making it complex with the names of that in such a numerical question, because we know BFS and DFS is a graphical approach and this is a numerical question, let's not take their names. Let's understand the approach and then we see how is the why is it we are calling it their approach. Okay, let's see. Here it is mentioned that n is only can be at minimum 2. Okay, so that means two digit numbers are the minimum case. But uh, why is it so? Say if our n is 1. Okay, so if our n is 1, what can happen? Is there any importance of k for us if our n is 1? Because if it's the single digit number, what's the importance of k? I mean, what will you do with the consecutive digits? The only one is there, only two is there, only three is there. There's no importance, right? So this comes out to be our best case. Now, see what I mean is that so 1, 2, 3, 4, 5, and similar way it goes up to 9. Fine, it goes up to 9. Now see, this is a base case. Now what we can look ahead with, we exactly don't know what our k is. Okay, we will start from the next digit, that is the second digit. Right, we exactly don't know what is our k is. So what we'll do, we'll consider this as our base, and then we will simply go ahead and what will be our steps? We will select one numbers at a time from this list or the array we have, and we'll simply go ahead with that. Okay. Now we have like first we say we put take one. Okay, and what's the idea? Now our idea is if this number, okay, the first number we took, if this number add it with k, okay, add it with k, say in our case k is uh 7. Okay, so once we are at the next step, that means is that n equals 2. Fine, so we are doing because this was n equals 1 and now we're finding out n equals 2. We don't know, like we are not looking forward to what the n is given to us, right? We are just finding out what the current, like step by step moving ahead. Okay, so we are n equal to 2. So we now know that this 1 uh, and this k is 7. So what can be the next number if we have 1? So we are sure that by simple brain, let's not understand the question. Let's understand like if we have 1 and we need a difference of 7, then what can be the number? Number should be 8, right? That's the idea. Now over here, how we can go ahead? We will get 1 by default from there, and we'll multiply this with 10. I mean, just moving it one bit to the left, right? Multiply this to 10 and then sum this with our k. Okay. So if we do that, what will be like not with our k exactly, but if we just sum k, that won't give a result, but k plus our current value, that is the 1. Okay. Why k plus our current value? This 1 is not k plus 1, rather k plus our current value. So if our current value is something like x, so k plus x. will be our value over here. But what we are trying to do over here, let's see. So what happened if we just make a like write this answer? This is like 1 into 10 is 10. So we take 1 and then k plus 1, that is k plus x is our 1 at this. So that is 18. We form 18. So if our it's a two-digit number, then we know that from 1 we can create 18, right? From 1 we can create 80 because that's what the question asking us. Fine. Now, similarly, if we need to go for n equals to 3, fine. If we need to go for n equals to 3, what would be our approach? Similarly, we will take this 18, fine, and here, look carefully, here we will simply check for uh, the last digit, right? If now we will actually store this to our x, fine, x equal to this value because x was initially our single digit number we took. Now it's the two-digit number we have, fine. So we got 18, and in that we will find that x mod 10. Say we mark it as y being our x mod 10, fine. So that's our 8 over here, right? We are trying to find n equal to 3. So in that case, how we can go ahead? Simply the same process we have this x into 10, right? This step because we need to move it one place left to add another bit or like another digit on the right. So simply x into 10, fine. So that's the initial process we did, and then simply we will add. We need to now check. Okay, see, we cannot do k plus x, k plus y in our case, right? Because it will go 8 plus our 7 will be something much larger than that, right? That cannot be a thing we can do. But what we need to do, we now need to check like that. There should be two kind of check. If x plus y is less than 10, in our in over here we find yes is true, but over here we find that no, it's not true. X plus y is not less than x. So what we will do, if we'll check if this y, that is this 8, okay, so this is the bigger number, remember that, y minus our k. If we subtract k from our y, is it greater than equal to 0? If it is greater than equal to 0, then see, both sides are like either one of them can happen or both can happen. Okay, I will tell you how. But see, in the for n equal to 2, we find that it went up to 18, like 8. Now we are seeing from the lower number. Fine. What's the lower number we can get? The lower number we can get is like 8 minus 7 is like 1. So it's like y, right? Y minus our k. So what will happen? X into 10. X was 18. So 1, 8, and then one bit is of blank. So y minus 8 is 8 minus k is 7. So 8 minus 7 is 1. So that's how we created a three-digit number. Okay. So I hope this idea is understandable to how we can go ahead and creating a two-digit, three-digit, and then we will look for the next like till we'll go ahead this with number of n, the total n size. Now, the question is, we now understand what we are supposed to do. Now, the approach is how we keep on finding the other numbers as well, because this is the finding of one number. Now, if we go ahead with like 1 8 and then we find for 181, that is we for each of the numbers in our in equal to 1 in this initial array, if we keep on finding the end result, like till the point we need to find, that is say n equal to 3. So if we keep on finding this first, okay, then this will go ahead as a DFS, because you took one number and you find it out the exact value or like all the value possible for that number. Okay, this will be an DFS approach. But what can be a BFS approach? The BFS approach will be a bit different. So in BFS approach, we will find all the two-digit numbers possible with k equal to 7. So that will be a second, like the first step. So we'll find all the two-digit numbers that are possible with k equal to 7. So 18, then you will go ahead with 29, fine. Then you will go ahead with 70, fine. Then you will go ahead with 81, fine. And then you will go ahead with 92. So that's all the two-digit number we find. So that's like the breadth of like breadth first search is going on, like a BFS approach. It's like we are finding all the two-digit number first. Then we are going for the three-digit number and finding all the three-digit number. Okay. So this is how why I say the approach is like whatever you are finding first. So you can do anyway. As we know, the idea is only with this trick. Idea is only with this trick, finding this x mod 10 and then finding if y minus k is greater than equal to 0 or y plus k is less than 10. If it is both, we should go for both. Because why? Why we should go for both? Say k is not 7. Say k is 2. Right? So in that case, what will happen? For 1, it will, as I said, for 1, it will give 3. And then for 2, it will give 4. And for 2, it will give 0. Remember, so it's like we are checking for this k plus x is less than like k plus x is like less than sorry, k plus y, this one, k plus k y minus k or y plus k. So we are checking y minus k is greater than equal to 0 or y plus k is less than 10. If both is possible, like 2 plus 2 is 4 less than 10, and 2 minus 2 is greater than equal to 0. Right? So that's the case. So we are just adding. So this is what we need to do. This is what the idea is. Okay. So let's quickly write the code and then we will understand how exactly this will be helpful. But in the code, we will use a different trick. The trick is we will not create this array by default. Okay. We will do a like a recursive run because we will go at the BFS approach, right? We'll find all the numbers here. So what we will do, whatever n is given to us, we'll keep calling n minus 1, n minus 1, n minus 1 until we find n equal to 1, and once we find n equal to 1 we'll have our particular array over us, okay, like a particular this single digit array. Then we go for finding n equal to 2 and we'll find all the n equal to 2 values we have, and then we keep finding till we find the particular n value we are supposed to find, right? So that will be our simple approach. So let's quickly write this code and then we will understand it again how this works with what we are trying to do. Fine. Fine. So here you can see like this is a 2 millisecond solution and pretty fast solution. Okay. So you found that this gave us a wrong answer. The wrong answer necessarily because if k was not greater than 0, like if k was 0 itself, because our constraints say that k can be 0 itself. So if k was 0, then it is creating repetitive numbers like 11, like as you saw, like it's giving us both side numbers. Okay, so 11 and 22 are this getting repeated because it was checking for both sides. Okay, so that's the check we have. Now, let's understand what we did exactly. So we took a case like if n is equal 1, then we simply return this array, the array of single digit numbers. But we know that n cannot be 1, so n can be minimum 2. So let's consider n is 2. So n came as 2 and this case not defined. So we simply call our function, recursive call to a function, and here we created our n minus 1 and k. We just passed it to that. So once n is because 1, because currently our n was 2, so previous array returned this array to our previous, because that's a recursive return. Now, what we'll do, we took an array list called temp, and then for each of the x in our previous, as we are discussing, we took an y that will be x mod 10. So in the first case, when it is a single digit numbers in our previous, then this doesn't really matter. But when it is like 2 digit, 3 digit number in our previous, then this x mod 10 is actually returning as the last digit available to us. Then where the simple thing we're doing is, if y plus k is less than 10, we're just adding it number multiplied by 10 plus y plus k. Okay. If y minus k is greater than equal to 0, so number multiplied by 10 plus y minus k. So it's like we are also keeping a check that is k is also greater than 0. So we did that for all the x in our previous array. Okay. Now once this is done, we simply check for this. Like we simply convert our array list, temp array list to our array being the array we have. Okay. Now once we have our array, we simply return our array. So that's the pretty easy concept, and this is the approach we are doing is BFS, because we in that we are finding all the 2 digit number, all the 3 digit number at once, and then we are going for the next digit number till we find the required digit number. But you can have another approach over here. The another approach is like a DFS approach, a depth first search. So what you will do, you will take single number, single digit number as well in the start, and then you just keep finding out all the numbers that are like in its depth. Like you will keep finding out the exact number that is the of required length. Okay, so if it is 3, so you will directly find out the 3 length number at first, and then you will find for the next number you will find the next 3 digit number. Okay, for the next like 1 digit number you will find the next 3 digit number, and all the 3 digit numbers possible to that digit. Okay, so that's the depth first search. So first you can actually find a 3 digit number after each instance, or you can go ahead with the all the numbers at once. So if you're going ahead with all the numbers at once, step by step, then it's a breadth first search. Okay, so that's the idea. Now, if we look carefully, if a k, okay, is if a k is like greater than equals 5, okay. So if a k is greater than equals 5, this k minus y is like y minus k may not be true in all cases. Okay. So in that case, our complexity comes down to order of n. But if a k is less than our y, that means we need to do two things at once. Okay, we are adding twice, adding numbers twice. Okay, so that gives us a, like for each of the x, we are adding numbers twice. So it's just increasing the space complexity as well. So it's like 2 to the power n is working when both are like if our k is less than equal to 4, if it's greater than equals 5, then it's complexity of order of n, because only one part is working for us. Fine. So that's more or less the whole idea of this question. So I hope you can understand, and you can see that this is a pretty fast solution as well. So make sure to comment down if you have any doubts related to question. I'll be happy to help you out as well. Also, like this video and subscribe to this channel for regular LeetCode videos like this. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.